So this was the end of the last video where we found out that some equations don't have any solutions at all. Let's continue with the same lesson, but now we're going to move on to the objectives. But first we want to understand that some equations are the total opposite. They will be made true by every single value ever used for the variable. So it's hard to illustrate because I'm not going to sit here and plug in every single number for x and show that every single one works. Let's look at a couple of them at least. Let's show you that both x equals -2 and x equals -13 are solutions. So by now you should have an idea that when it says show, what I'm going to do is I'm going to plug the numbers in for x and look for truth, look for a true equation. So if I plug -2 in on the instance on the left-hand side, I have a question that I need to answer. Is that true that the left-hand side equals -10? And then when I plug in the completely different value that I'm testing for x over here, 13, let's see if that turns out to be -10. So I'll simplify the left-hand side of each, and I'll do that following the correct order of operations. And I will ultimately find out that both of these equations, the left-hand side is equal to -10, and the right-hand side is equal to -10. So yeah, it turned out that -2 made this first equation true, and 13 made this equation true. So I wonder what that would look like if we were trying to solve this thing. Because we're used to solving things, and we have two scenarios so far. One is you boil it down, and you get x equals a number. And that we don't have x equals a number or another number. We have x equals a number. And then we saw in the last video that sometimes the variable disappears altogether and you're left with something that's just not true. There's two numbers, one on the left side, one on the right side, that don't match. And when it says there's equal to each other, you go, well, there were no solutions to be had here. So let's see, what it would look like if we tried to solve this equation. So I would start by simplifying the left-hand side. In this case, the order of operations says to distribute -5. So I would certainly do that. And after I distribute the -5, it looks like I have some common terms, some like terms there to simplify. So I'll add the 5x and the -5x together, which basically cancel each other out. You get a 0 there. And I get -10 equals -10. That's the same thing we kept seeing before. What happens is this left-hand side, no matter what value of x you use, I didn't plug an x value in. No matter what value of x you were going to use, this side was going to turn out to be -10. So no matter what x value you used, this was going to be a true equation. But I would say this, when you go about your business and you're trying to solve the equation the best you can, if the variable disappears altogether and you have a true statement at the end where two numbers that are equal to each other are on either side of the equation, then you would say the following. Since -10 will always equal -10 no matter what x we use, then there's no value of x that makes our equation untrue. There's no value of x that makes our equation untrue. So that means that every value of x makes it true. So we would say that the original equation has all real numbers as solutions. So let's summarize that. We should now know not to panic if when we're solving equations, the variable completely disappears. That's whether we're applying inverse operations and we watch the 3x's go away at the same time and all the x's disappear, or whether you're simplifying a side and you find that these like terms cancel each other out. When no variable remains at the end, you now turn it into a true-false game, where if the resulting equation that has no variables in it is true, then our original equation had all real numbers as a solution. And if the resulting equation with no variables in it turns out to be false, like on the left, then our original equation had no solutions. So from here on out, when you're solving equations, just trust your processes, trust your inverse operations, trust your equivalent equations. And if the variables disappear, we're not going to panic.